And so the first subject of the Unconference was Timon, PT write before and after the operation with acquire and release semantics. So we discussed this with, I'm sorry, I forgot, 1,000. And we agreed that perhaps it will be possible to determine if the before or after operation is necessary by doing a stress test on the model, for example, by using LibRCU regression standard tests. And if Timon passed through that, we can pretty much guarantee that it supports correctly the implementation of T-SANS. However, if we can prove that it does not by failing a test, then we have to go back to the blackboard and see what is the relationship with before and after the operation for PT write. There was also some concern about PT write being reordered by the CPU with memory access. So it is not stated in the Linux Intel manual if PT write is like CPU ID, a synchronization instruction. So probably a statement, serialization instruction, thank you. So probably a statement from the vendor will be necessary, I don't know. Or because even if we prove it for an architecture, a model of CPU, it might break for another microarchitecture. So it's probably better to ask Intel directly. And I think that's pretty much covered this part. So the other topic was libside support for span range ID. I think it was related to OpenTelemetry span range mostly, but it can apply also to other framework. There was mention of do we want per thread work or do we want to have share work that can move across thread, right? With the ID moving from thread to thread. And then there was question about do we have a single span ID in libside as a TLS, as a stack TLS, or do we want tracer, I guess, that was providing the span ID to the libside? And I think that the conclusion was that probably that one span ID was enough probably from libside point of view, and a TLS will be sufficient for that.
Yeah, I mean, from the discussion, I think it appears that the span ID information really belongs to the instrumentation area rather than the tracer per se. So having facilities to keep track of something as common and useful as a span ID kind of makes sense for libside. So the part about libside and Tracy. So Tracy is a tracer mainly for the gaming use cases. And there were several questions about how libside could fulfill the requirements from Tracy. Both in terms of the types that are needed, the data that needs to be emitted and found in the trace. So many of the requirements tend to be more tracer requirements than fitting in the libside, I would say, area or but libside can be used to convey that information to a tracer. So that's the short summary about it. Maybe I missed some things.
There was also discussion of runtime integration. Yeah. So it's unrelated, but it was a tangent. So there was some concern first for maybe porting libside to another operating system, and we conclude that it was quite trivial to do by just following the calling convention of the operating system and by providing a means for the tracer in the kernel of the operating system to have access to libside data through user event for Linux, and I forgot the name for ETW for Windows. So those are like the two things to make it portable for the OS. And we conclude also that the layout, the ABI for the data structure that libside defined is the same for both or every operating system, basically. As for the runtime, we mentioned that there might be some problem with runtime cooperation, for example, in Golang with fibers or Go routing. Java have the same problem probably. Basically because if we have a TLS for a thread, a kernel thread, then if there's a context switch or something like that, the stack change.
I mean, mainly in the context of keeping context ID in a TLS. So for that, we need cooperation of the runtimes if they have fibers. But it was not that much of a problem if we just look at the areas of libside where we're calling a tracer, because this is basically calling C code and the runtime should not schedule fibers over that.
But there was also some concern that in Golang, when calling C code, it was scheduled on another kernel thread. And so you might end up getting the wrong TLS access. And so there was mentioned to use maybe dynamic instrumentation to bypass the scheduling of C in this runtime Go.
Or adapt Golang.
Yeah, or use not a wrapper, but a helper library with libside for each runtime that will do the cooperation. And I think that pretty much concluded.
Anything we missed participants? All right. So, well, thank you for attending this first day of the Tracing Summit. We'll be back tomorrow at around 10, is it? Same hour, 10 o'clock? Yeah. It's
Well, yeah, if you don't have your badge, but since everybody here has a badge.
yes. At what time does it start tomorrow? That was the talks start at 10:15 tomorrow morning. So be there on site at 9 o'clock for coffee and snacks, and we'll start at 10:15. So thank you very much. Have a great evening. See you tomorrow.